So here we are to the part 2 of alcohol. So basically in this we will be dealing about the chemical properties of the alcohol, profoundly the important ones. So the chemical properties of the alcohol, they're divided into three groups on the basis of breakage or bondings. So now these reactions are not that complex, but they are slightly confusing. Like while revising these reactions, it might be confusing, like you might get confused with the older reactions. So it's very important that you be clear with the older reactions, the previous chapters, and then go for this. So see, the before going on to the chemical properties, I have one question about the physical properties. Like in the last video I told you about the solubility. Similarly, one more physical property is their boiling point, and this question has been asked many times, like why the boiling point of alcohol is more than that of normal aliphatic any compound like normal alkane. So the answer is very similar to the solubility. The formation of hydrogen bond is the reason. Like I told you, this hydrogen bond is formed. So this hydrogen bonding, this bond, it requires excess energy to be broken. Like we know that the boiling point means what? The bond gets broken and then it gets vaporized. So that's the boiling point. Now since there is hydrogen bonding between two molecules, two alcohol molecules, so it gets more difficult and it needs excess energy for the bond to be broken, and that's the reason why the boiling point of alcohol, it is more than that of any normal alkane or alkene. And the boiling point, it goes on increasing with the increase in number of carbon atoms, because I told you that this R, it is electron repelling group. Actually we call it electron donor group. It goes on giving electron towards this. So more the number of alkyl groups, more the electron density will be here, and more stronger will be the bond between them. So 3-degree alcohol is more it means it has higher boiling point than 2-degree alcohol, and 2-degree alcohol has higher boiling point than 1-degree alcohol. So that was just a question for 1 marks. Now coming back to the chemical properties, I told you it is divided into 3 parts. So first part is that the reaction in which there is breakage of the OH bond. Now we know alcohol means ROH. Now sometimes in some reactions what happens is that this OH bond gets broken, and in place of hydrogen something comes and gets added. But in some reactions this entire OH group this bond gets broken. So this entire OH group, it goes away and something comes and adds to this R. So this is the second type in which there is involvement of breakage of ROH bond. This bond between ROH gets broken. Here only the bond between OH gets broken. And the third type is which involves the entire alcohol. We will read about each of them in detail. So first of all, I'm just telling you the basics of each and every reaction, but the reaction is not asked so simply. Like the question might be coming in form of conversion, but for conversion you need to know that which reagent we need to use. So that's the importance of this chemical properties. Mostly in alcohol conversion questions come. Now sometimes they may tell you like convert the ethanol into ethanoic acid. So this is the type of oxidation reaction. So in this way we need to understand that which type of reaction is asked. So first of all, we have the reactions involving breakage of OH bond. So in this first we have acidic nature. Now with the chemical reactions I'll be telling you what type of questions are asked in this. So see, in acidic nature the question will be asked in this way, like show the acidic nature of alcohol, or why is the OH group of alcohol acidic in nature. So see, this is a normal alcohol, structure of alcohol. Now acidic nature, why is alcohol acidic? Because whenever it reacts with any of the highly reactive metals, like let's take example of sodium, because it is very highly reactive metal. So whenever it reacts with sodium, this hydrogen gets removed and Na comes and adds. So it becomes RONA, and then hydrogen gets removed. It means H plus gets removed. So we know that acidic nature means what? Any of the acidic character means it is giving H plus ion. Like suppose HCl is acidic because it gives H plus and Cl minus ion. It means H plus is getting removed, created actually. So even here the H plus is getting liberated, hydrogen gas is getting liberated. So H plus ion is getting produced. It means here H is getting displaced by any highly reactive metal, and this shows the acidic nature of this alcohol. This is basically known as alkoxide ion. Okay, so with example, like let's take the example of any alcohol, CH3 CH2 OH. So whenever it is reacted with any of the highly reactive metal like sodium, what will happen? This hydrogen gets removed and Na comes and adds. Now why hydrogen is getting removed, why not completely OH? Because this is a reaction which is involving the breakage of OH bond. It means the bond between O and H will get broken. So O and H got broken and Na comes and adds. So CH3 CH2 O Na plus H plus. So another question which might be asked from this acidic nature is that to compare the acidic strength of alcohol and water. Like sometimes you can be told that why alcohol is weaker acid than water. I told you this is acidic in nature. So this alcohol is acidic in nature, but it is a very weak acid. So weak that it cannot change the color of litmus and it cannot react with any of the base. So why it is so weak acid and why water is more acidic than this alcohol? So if we compare both of them, like alcohol is ROH, so according to acidic nature this H plus is there and RO minus ion is there, isn't it? You'll understand this right now. See, water means ROH, HOH, H2O, so H plus plus OH minus ion. Water gives H plus and OH minus ion, H plus and OH minus. Similarly, alcohol gives H plus and RO minus. So this is the reason why RO minus comes. So in this way, these are the two acidic structures. Now see the basic reason why alcohol is less acidic than water. As I told you that this alcohol, this alkyl group in the alcohol is an electron donating group. It means that, first of all, understand this very clearly and then I'll tell you how to write it in examination. So see, this is ROH. We know that alkyl group is electron donating group. I told you about this even in the hydrogen bondings in the physical properties. Like this alkyl group is electron donating. It pulls the electron towards this oxygen. So the electron is getting pushed towards this oxygen. So when it is getting pushed, minus charge is created here. Now understand one thing, why a compound is acidic. If you see any compound, for example, let's take HCl, okay, or simply let's take water. Do not go to any of the acid right now, we are comparing with water. So see, water, what happens is that this H plus is getting released. But how is H plus getting released? H plus means there is lack of electrons. So what happens is that this oxygen, it withdraws all the electrons of this bond. So it withdraws all the electron of this bond and it gets minus, it gets positive. Since it is withdrawing all the electrons of this OH bond, this bond gets broken. So in this way it has minus charge plus, this bond is broken, so H plus is there. In this way H plus and OH minus is getting created. In this way basically the acidic nature is being shown. But when you go back to alcohol, you see that this alkyl group is pushing the electrons towards this oxygen. So the electron density is already higher at this oxygen. It means it already has electrons. So it does not show much tendency to withdraw the electrons from this bond. Since the electrons are not being withdrawn from this bond easily, so this bond is not broken easily. Now for the bond to be broken, this oxygen should withdraw the electrons from this bond so that this bond gets broken and H plus gets released. But now here already the electron density is higher because this alkyl group is pushing the electrons towards this oxygen. So in this way the bond is very difficult to be broken. So this is the reason why H plus is not created easily and alcohol remains less acidic than water. So this was just a simple explanation. Now in examination, if it is said to write, you can write in this way. Like in alcohol we have electron donating group, alkyl group, electron donating alkyl group. This is alcohol. So this alkyl group is the electron donating. Now it increases the electron density at oxygen. Electron density is increased at oxygen. So due to this, it does not so much tendency to withdraw the hydrogen, withdraw the electrons from the hydrogen, and this is the reason why H plus does not get created easily, or simply OH bond does not get broken easily, and so it is less acidic than water. Once again, if you didn't get this, it's very simple. Any compound to be acidic, like water, to be acidic, this bond needs to be broken and H plus needs to be released. For any compound to be acidic, H plus ions should be released. Now basically, if you see, logically speaking, H plus will be removed only if this bond is broken and this hydrogen has no electrons left. Plus means lack of electrons. So if H plus is getting released, it means that all the electrons is getting removed from this hydrogen, and all the electrons are being pushed by this oxygen. Simply, all the electrons are being taken by this oxygen, and so there is no electron left in this hydrogen, so it becomes H plus. So this oxygen withdraws the electrons of hydrogen, or simply the bond, so that H plus is released. This is normal acidic case, but in case of alcohol, it already has more electrons, because alkyl group is electron donating group, so already electron density is higher at oxygen. So this is the reason why it is not interested in withdrawing the hydrogen electrons, and this is the reason why H plus is not released easily, and so it remains less acidic than water. This is a 1 marks question, rarely asked but very simple. Just the understanding was a little bit different, but logically it's very simple. So with this we complete the first type of reaction, the acidic nature. Then the second type of reaction is the reaction with carboxylic acid. Now again, this reaction is very important reaction. This is one among the, I'll teach you 7 reactions of this alcohol, and among the 7 reactions, this reaction has the 3rd place in the importance. Okay, so you need to understand this reaction very properly. So this reaction is also a type of reaction which involves the breakage of OH bond. So simply, first of all, you need to understand what is carboxylic acid. We'll just react this alcohol with carboxylic acid. So we need to understand what is carboxylic acid. So see, carboxylic acid means RCOOH. This is carboxylic acid. Now basically, if you see, carboxylic acid is a mixture of carbonyl group, it means ketone and alcohol. How? See, this is ketone and this is OH, alcohol. So whenever this ketone and alcohol mix together, so it becomes OH, this, and here any alkyl group is there. So in this way, RCOOH is carboxylic acid. It is a mixture of ketone and this alcohol. Basically, ketone is this, are alkyl groups, both of the sides of ketone. I told you in the last video in the Grignard's reagent. So this R is removed and OH is there. So RCOOH. This is the basic structure of carboxylic acid, RCOH. While writing, we just write RCOOH, but here is a double bond because this is a ketone. So see, this carboxylic acid RCOOH is getting reacted with alcohol. This is ROH, alcohol. So in this reaction is carried in the presence of conc H2SO4. Now you'll come to know why we are using conc H2SO4. First of all, let's complete the reaction. It takes place in the presence of conc H2SO4. It's very simple. Reaction is not that tough. Only this H2O needs to be removed. This H2O removed. So RC. If H2O is removed, this OR will go and add there. Very simple reaction, very similar to that Grignard's reagent, preparation of alcohol from Grignard's reagent. But remember, do not get confused. In that Grignard's reagent, this bond was getting broken, minus charge was getting prepared, and then some other thing like that, this R was coming and adding here. So it was such kind of reaction. So this is not similar here. No bond is getting broken. Here simply this OH and H, they react, so H2O is removed, it means water is removed. Now it's very simple. This is the reaction involving breakage of the OH bond. So this is alcohol, so this OH bond should be broken. So this OH bond is broken along with this. So this H2O is removed and the remaining one this the remaining one comes and adds there. So this is the remaining one, and the remaining one comes and adds here. So in this way, RCOOR, now the remaining one is water is removed. So this RCOOR, this is known as ester. Okay, this compound is known as ester. RCOOR, you'll just need to mark this thing up right now. RCOOR means ester, and due to this reason, this carboxylic acid, this reaction is also known as esterification. Remember the name, this reaction is known as esterification. So what is esterification? It is simply the reaction of alcohol with carboxylic acid, which involves the removal of water. So now the question is that why H2SO4 was getting used. Now if you see this reaction properly, so basically the reaction is RCOOS. Remember the formula of carboxylic acid. This formula will be used in the further chapters as well. So this water is removed. You can simply write the remaining one like this, and then this OR plus H2O. So ester is getting prepared. In place of R, any alkyl group can be there. There can be CH3, then can be CH3CH2. So why H2SO4, conc H2SO4 is getting used? So if you see this reaction properly, what will happen is that this is a type of reversible reaction, to be precise. This water, it reacts with this formed ester. This is the ester which is formed, and this water which is formed. So what happens is this water reacts with this ester formed, and then this H goes and adds their RC. You do not need to remember this, I'm just showing an example. So this H goes and adds there, and the remaining one ROH. So in this way, you can simply remember that this is a type of reversible reaction. One hydrogen goes and adds there, and remaining OH goes and adds here. So in this way, again carboxylic acid and alcohol gets prepared. Again I'm telling, this is not the thing to be remembered. I'm just showing you that again carboxylic acid and alcohol is getting prepared. So this is a type of reversible reaction. But conc H2SO4 is a dehydrating agent. If you know, conc H2SO4 is the best dehydrating agent of all. It just soaks up all the water. So if you use conc H2SO4, it will soak this water up, and if it soaks this water, then this reaction will only drive in forward direction. It will not go to backward direction. So this is the reason why H2SO4 is used, and this is an important question which is asked. Like it might be simply asked why H2SO4 is used in esterification. So you need to remember, H2SO4 is a dehydrating agent. It helps the reaction to drive in the forward direction, not to go in the backward direction. Otherwise, again that carboxylic acid and alcohol will be prepared. So these were the two kinds of reaction which were involving the breakage of OH bond. Then we have the second type of reactions. These reactions actually, they involve the breakage of COH bond, or simply ROH bond. It means this, till now we were breaking this bond, OH bond. This is ROH, so we were breaking this bond. Now we'll break this bond. Now the reaction which is the most important one and holds the second position in the list of importance is reaction with the phosphorus halide. Though this reaction is very simple, but this is very important reaction. So phosphorus halides means what? Phosphorus P, halides means any halogen, Cl, and we know PCl5 is there or PCl3 is there according to the valency, or simply PBr3 is there. So in this way you can take any of the halogen. Let's take Cl. So this reaction is very simple. Alcohol, we are reacting alcohol. This is the reaction of alcohol. So take any alcohol. Let's take CH3 CH2OH. So this is alcohol. Now you can take any of the compound, PCl5 or PCl3. We'll take PCl5 first. Now this is very simple. We know that this is the breakage of complete ROH bond. So simply this whole OH will get removed, because this is R, this is OH. So bond between them will get broken, and this chlorine will come and add there. So CH3, CH2, and then Cl. You can simply use logic like CH3 CH2OH, and it is reacting with PCl5. So obviously phosphorus is not going to come and add, chlorine will come and add. So you can simply use logic if you do not remember. So CH3 CH2Cl. The remaining one in organic chemistry, it is not important to write, but still if you want to write, it will be POCl3 plus HCl. It will just confuse you, so leave it, don't write. So CH3 CH2Cl, very easy reaction. Simply if you react with PCl3, the product will be the same, nothing different. CH3 CH2OH plus PCl3 is there, this chlorine will come and add, OH will be removed, CH3 CH2Cl plus again if you want to write you can write, but this thing you need to remember, so leave it. So CH3 CH2Cl, in this way alkane is getting prepared. Yeah, sort of nucleophilic substitution reaction, we read about this in haloalkanes and haloarenes. Cl is a sort of nucleophile. It comes and replaces OH, so it is a type of nucleophilic substitution reaction. Why chlorine is nucleophile again, if you remember? Because nucleophile contains electrons and chlorine has 7 valence electrons. It is rich in electrons. It just goes and replaces OH, and since it is rich in electrons, it is nucleophile. So this was a type of nucleophilic substitution reaction, very easy but though very important reaction. Why this is very important, I'll tell you at the end of all the chemical reactions, because a very long conversion is asked. In that conversion, this PCl5 and PCl3 comes in first step. So moving on to other reaction, another one is reaction with halo acid. Again, this reaction is also a very easy reaction. Okay, this is also a type of reaction involving breakage of COH bond or ROH bond simply. So nothing different, just in place of PCl5 we have halo acid. Halo acid means HCl or HBr, HF, anything. So simply take an alcohol, CH3 CH2OH. The mechanism will be same, OH removed, chlorine comes and adds. Very similar to this, nothing different. CH3 CH2 Cl plus H2O is formed because the hydrogen and OH, so H2O is formed. So in this way again alkane is being formed again, which is a type of nucleophilic substitution reaction. But remember, this takes place in the presence of Lucas reagent. Lucas reagent means ZnCl2. okay, so till now only one I have told you which you need to remember, ZnCl2. Rest of the reactions are not that important because H2SO4 here, esterification, this question will itself give you why H2SO4 is used there, and the rest of the reactions no such reagent is there. So this is the first type of reagent you need to remember, ZnCl2 in halo acids. Though this reaction is not important, pretty much the end of the reactions in the importance list. Still need to remember this reaction because sometimes it has been asked, like what happens when alcohol is treated with HCl in this much degree Celsius, this much degree Celsius. So this was all about the breakage of COH bond, and now the final type, which has the most important reactions in it, which involves the whole alcohol molecule. So till now we learned about the 4 types of reactions. First was the acidic nature. Very simple, hydrogen removed, any reactive metal comes and adds. From this many questions can be asked. I told you about the questions, breakage of bond and all, electron density and all. And then second was the carboxylic acid, which was esterification. Very simple, we treat it with carboxylic acid, which is RCOOH. In this H2O gets removed and the formation is ester. Why we use H2SO4 here? Because this is a type of reversible reaction, and this H2SO4, it is a dehydrating agent which soaks up all the water and does not let the reaction to go in backward direction. Then we learned about the phosphorus halide. Phosphorus halide and halo acids are very simple. Simply you react with phosphorus halide, chlorine will come and add here in place of OH. Here again chlorine will come and add here in place of OH. Only the reagent is different. HCl here, PCl5 here. Now the important one starts and the complexities start. So the first reaction among them is the reaction with conc H2SO4. Now as I told you, we have a list of importance, and in that list of importance this reaction holds the first position. So the reaction with conc H2SO4 is the most important reaction in this entire alcohol chapter. Now this question has been repeatedly asked many times, almost 10 or 15 times in the last 20 years. So see, from here we begin the reactions in which you need to mug up the things. From here, if you cannot understand the reaction, you will just need to mug up, because this is very important reaction. So the reaction is that we react alcohol with conc H2SO4, but the complexities, as I told you, the complexities here are, we have two cases here. Like, the cases are on the basis of temperature we use. Like, if we do the reaction, we conduct the reaction on 100 degrees Celsius or 110 degrees Celsius, around that, and if we conduct it in 160 degrees Celsius or 170 degrees Celsius, and one more case is there about 140 degrees Celsius, though it is not that important still. So it is on the basis of temperature. There are three cases. It means different types of compounds or products are formed as a result of different types of temperatures. So first, let's go to 110 degrees Celsius. So CH3CH2OH, basic alcohol, ethyl alcohol or ethanol, it is treated with conc H2SO4 in the presence at 110 degrees Celsius, first case. So in this case, what will happen is that, simply we know H2SO4 means an acid. So H2SO4 is acid. As I told you, that acid gives H plus, and remaining one is, if H plus and the remaining one is one more hydrogen and SO4, so HSO4 minus. So H plus ion and HSO4 minus ion, it gives these ions. So here what will happen, here this completely OH group will get removed and HSO4 will come and add CH3, CH2 and HSO4. So this is the thing, and the other one H and OH, it will form H2O. So this is the first type of reaction in which this CH3, CH2, HSO4 is getting prepared. If you go for the naming, CH3, CH2 means ethyl, H means hydrogen, SO4 means sulfate. So ethyl hydrogen sulfate is being prepared. So this is the first case. Very simple. CH3, CH2OH, when it is treated with conc H2SO4, what will happen is that completely OH group will get removed and HSO4 will come and add. Why I showed you this? Because simply if I would have shown you this, then you would get confused, like H2SO4 is there, then why HSO4 comes and adds, why not H2SO4? So see, H2SO4 basically it gives H plus and HSO4 minus ions. Now HSO4 comes and adds here, and this OH goes and adds there, because see, this CH3 CH2 OH, when this OH will get removed, so CH3 CH2 will have positive charge plus OH will have negative charge. So obviously this negative charge will go and attack to the positive one, it means H plus, so water will be produced, and the remaining one positive and negative attracted, so HSO4 will come and add here. So this is the first case, and trust me, this is the most simple one case. So then we have the second case. The second case is that we treat it at 160 or 170 degrees Celsius. So CH3, CH2OH, when it is treated with conc H2SO4 at 160 to 170 degrees Celsius, then in this case it is very simple. OH gets removed from this carbon and hydrogen gets removed from this carbon. Yeah, we have learned this type of reaction, and that was dehydrohalogenation reaction. If you remember, it was CH3, CH2, Cl. We were treating with KOH, alcoholic KOH. This chlorine was getting removed from one carbon, and from adjacent carbon hydrogen removed. And so if hydrogen is removed, CH2, chlorine is removed, CH2, and one more bond would be there. So in this way alkene was being prepared. That was dehydrohalogenation reaction, and it was in haloalkanes, haloarenes. It was a reaction of haloalkane, haloarene in the presence of alcoholic KOH. Here it is pretty much different. It is a reaction of alcohol, OH is there in place of chlorine, and it is being prepared, it is being conducted in the presence of conc H2SO4. So OH is getting removed from this carbon, and from adjacent carbon hydrogen gets removed. Hydrogen removed and CH2 remaining, even here CH2 remaining, and one more bond needs to be there, so double bond between them. So alkene is prepared. In both of the cases alkene is prepared, but the reactions are different. Here chlorine, it means halogen, and hydrogen was getting removed, so it was dehydrohalogenation reaction. Halogen also, hydrogen also, so dehydrohalogenation reaction. Here hydrogen is removed and this OH is removed, so it is known as dehydration reaction. Okay, this is the reaction of alcohol, this is the reaction of haloalkane. So do not get confused between them. It is in the presence of alcoholic KOH, it is in the presence of conc H2SO4. Comparison is necessary for remembering. So alkene is being prepared, but this is dehydrohalogenation, this is dehydration. So the reaction of H2SO4, the reaction of alcohol with H2SO4 at 160 to 170 degrees Celsius is known as dehydration reaction. It involves the formation of alkene, and the remaining one, hydrogen and OH, obviously H2O will be formed, one hydrogen and one OH, so H2O. So these were the cases. First case, simple, HSO4 comes and adds, in this case alkene prepared. And the third case, which is the last case of this H2SO4, it is a case of 140 degrees Celsius. So now this is the case basically in which excess of alcohol is being heated with conc H2SO4. So when you heat excess of alcohol in 140 degrees Celsius, so excess of alcohol simply we represent by drawing two or more than two structures. So see, CH3 CH2 OH, let's make bond between them, and more alcohol, so it means excess, so CH3 CH2 OH in the presence of conc H2SO4 at 140 degrees Celsius. So when we do this reaction, what will happen is that again water gets removed. You need to remember, water is getting removed in each and every reaction of this alcohol, and it will make easier for understanding. Like even here, if you remove the water H2O, you can simply remember we have to remove OH from here and H from here, so the remaining one will come and add here. Simply HSO4 will be remaining, so you will not need to remember all this mechanism. So similarly, you can say in this second case, this OH is getting removed, H is getting removed, because we need to remove water anyhow. So H and OH, so remaining one will be CH2 CH2, and it has 4 bonds, so double bond is formed. Similarly, in third case, water is getting removed. We need to remove water in any case, so simply see, only one way of removing water from here is we remove OH from here and one hydrogen from here, or vice versa. You can remove OH from here and one hydrogen from here. So in this way, water gets removed and the remaining one will be added with each other. So see, first write this one, CH3 CH2O is there, and one more bond, and the remaining one CH3 CH2, or vice versa can also happen, like H can be removed from this and OH can be removed from this. Simply you see that this is prepared, which is a type of ether. If you remember, I told you this is the formula for ether. If you see CH3 CH2 CH3 CH2, there are two ethyl groups, so it is known as diethyl ether. So these were the three cases of H2SO4. Let's see once again. The first case was very simple. The first case was at 110 degrees Celsius. So whenever we conduct this experiment at 110 degrees Celsius, this OH will be removed and one hydrogen will be removed. So H2O is formed and the remaining one will go and add here. So CH3 CH2, remaining one means what? One hydrogen is removed. It means HSO4 is remaining from H2SO4. So HSO4. So this was the first case. In second case, CH3 CH2 OH, it was being conducted at 160 to 170 degrees Celsius. Here OH from this and H from this. So CH2 CH2 plus H2O, one more bond is formed there. So this is the second case. Now third case, excessive CH3 CH2 OH plus CH3 CH2 OH. It's being conducted at 140 degrees Celsius. You need to remember the temperatures: 110, 160 to 170, 140. This is not that important. These both are very important. So now you can remove any, like remove hydrogen from this and OH from this. So H2O is removed and the remaining one CH3 CH2O, write this and then write this, CH3 CH2. So ether is formed, diethyl ether is formed. So these were the cases of reaction of alcohol with the conc H2SO4, which is known as the dehydration reaction. Then we have the reaction with alumina. Now reaction with alumina is very similar to the reaction with this conc H2SO4. Only the first case is not the rest two cases are the same, like CH3 CH2OH. Now first of all, what is alumina? Alumina means Al2O3. Okay, remember alumina means Al2O3. So it is reacted with Al2O3. So when it is reacted with Al2O3 at 350 degrees Celsius, this reaction is not very important. So if you cannot remember this temperatures, it might be confusing you. So leave this reaction if you want. But the reaction is very simple. OH will be removed from this, H will be removed from this, so CH2, CH2. Yeah, same reaction as this one. Only the reagent is different. Here the reagent was H2SO4 at 160 to 170. Here the reagent is Al2O3 at 350 degrees Celsius. Even here one more case is there if we use excess. So if we use excess CH3 CH2OH plus CH3 CH2OH in the presence of Al2O3 at 250 degrees Celsius, then same case, OH from this, H from this. It means simply CH3 CH2O CH3 CH2 will be formed. It means this will be formed. These both cases same, ditto copy, okay, in this alumina, nothing different, only the reagent is different and the temperature is different. So conc H2SO4 and alumina very similar, only the first case doesn't happen in alumina. So till now we have learned 6 reactions and the final reaction, which is probably the toughest of each of them. Okay, of all of them this reaction is very tough, and here you might not be able to understand this reaction. So it's necessary that you mug this reaction up, because this oxidation, which is the third reaction of this kind, or the 7th of all kind, this reaction holds the 4th position in the list of importance. So in this oxidation reaction, what happens is that this alcohol RCH2OH, or I have written in this way because in this reaction this representation is necessary. Now remember, in oxidation usually conversion will be given. It means in this type of question conversion will be given, like identify the compounds, or simply convert this compound into this. So 2 types of question from this, one is conversion, another is identification, and it is very necessary to write in this form. Basically it is ROH, but this CH2 is a part of alkyl group like CH3 CH2OH. So this CH3 is also R. I wrote in this way because we'll be needing this. You'll understand why. RCH2OH, we are doing oxidation. Oxidation means what? We simply treat it with any of the oxidizing agent which provides the oxidizing reagent, means like nascent oxygen and all. So nascent oxygen is being provided by the oxidizing agent. Oxidizing agent can be KMnO4, or simply it can be K2Cr2O7. Usually K2Cr2O7 is asked. So it has 2 steps. In the first step, what will happen is that an aldehyde will be formed. Now how aldehyde is formed? There are 2 ways to remember it. First way I'll tell you. See, first of all, you can remember in this way simply that this is oxidation reaction. So obviously hydrogen will be removed. Oxidation means what? Addition of oxygen, removal of hydrogen. So this hydrogen from this carbon is getting removed. So if it gets removed, it will be in this way, but carbon has 4 bonds. So we'll write it in this way. So 1, 2, 3, 4. Here only carbon had 2 bonds. If we write this oxygen up here by forming 2 bonds, it will have 4 bonds. So in this way aldehyde is formed. This is the first way to remember. Now the second way to remember why aldehyde is formed, you just remember that water is removed. Like this is RCH2OH. Water is removed. So if water is removed, OH along with one more hydrogen will get removed, isn't it? So what will be remaining? RCH will be remaining, okay? And now it is oxidation, so oxygen will come and add to this carbon, and it will form double bond because carbon has 4 bonds. So I guess this way is very easier to understand rather than this one. So let's go on with this way. So again from the beginning, RCH2OH, this is the alcohol which is being oxidized by, let's take K2Cr2O7. So what will happen? First of all, water will be removed. Okay, so if water is removed, so OH and one more hydrogen is removed, so RCH, one more hydrogen is remaining, and now it is oxidation, so oxygen will come and add. So in this way aldehyde is being prepared in the first step. Now in the second step, further oxidation will happen. On further oxidation, K2Cr2O7 which is providing, so further oxidation is happening, so RCHO, this aldehyde, it is being further oxidized. So on further oxidation, this oxygen will come and add to carbon again, so it will be added to this carbon again. It is just coming in between this carbon and hydrogen. Okay, you can even add here, but then you need to break this bond, so we do not add here, we just add here and then add oxygen. So in this way the complete reaction would look somewhat this kind: RCH2OH plus first oxidation. First of all, what happens is that K2Cr2O7 which is providing the oxidizing agent, nascent oxygen, first of all water gets removed. So if water gets removed, it will be RCH, and it is oxidation, so oxygen comes and adds. Now on further oxidation, again more oxygen will come and add because it is oxidation, so it will come and add in between this. So in this way finally what is formed, this is carboxylic acid, if you remember, RCOOH. So carboxylic acid is being prepared from alcohol. So this is the reaction which is very important. Okay, this reaction is basically asked in the form of conversion, or like first of all it can be given like convert ethyl alcohol into ethanoic acid. Remember, ethanoic acid means carboxylic acid. Whenever it is said ethanoic acid, OIC acid, it means it is a sort of carboxylic acid. Ethanoic acid means what? It comes from ethyl group. So we need to prepare CH3COOH. We need to prepare CH3COOH. Why ethanoic acid? Because say CH3 means you can get confused that it should be called methanoic acid, but it is not methanoic acid, it is ethanoic acid, because it is coming from ethyl alcohol. If you see this, it comes from ethyl alcohol, or basically you can remember that there is 2 carbon, so ethyl. Okay, 2 carbon, this is the simpler way, 2 carbon, so ethanoic acid. So you need to prepare ethanoic acid from ethyl alcohol. So you know that this is carboxylic acid. The only way to prepare carboxylic acid from alcohol is oxidation. So this is the reason why I told you that these reactions need to be marked up. Like which reaction can be asked in which way, we do not know. If you remember the first reaction, it means the first case we learned was the acidic nature, and then we learned similar reaction with carboxylic acid, and this is reaction involving production of carboxylic acid. So these two are different cases. So first of all, this case can be asked, the answer is this. And sometimes what happens is identification can be asked, like in this way, compound A will be given and then K2Cr2O7, and it will given minus H2O. B, again K2Cr2O7, C. So identify A, B, C, and in place of C, simply one compound can be given, like ethanoic acid is given, CH3COOH. Okay, so in this way you need to identify A and B. So what are A and B? So you need to see this CH3COOH is there, ethanoic acid. Ethanoic acid will come from ethyl alcohol. Similarly, propanoic acid will come from propyl alcohol. So it's very clear that this is a first of all, if you see K2Cr2O7, you need to be clear that this is oxidation reaction. Oxidation reaction in which carboxylic acid is being prepared. It's the reaction of alcohol. Ethanoic acid comes from ethyl alcohol. So compound A is ethyl alcohol for sure. So if you know compound A is ethyl alcohol, then you can simply know B. Why? What is B? Like say ethyl alcohol CH3 CH2OH. It is given that it is being oxidized minus H2O. I told you that aldehyde is being prepared. So CH3 CH2, sorry, not CH3 CH3 CHOOH. O. This will be prepared. To be clear, I'll show you here. See, CH3, CH2, OH. It is getting oxidized, water is getting removed. We know that this is alcohol because oxidation reaction involving carboxylic acid is always alcohol, and it is ethanoic acid, so it is ethyl alcohol. So ethyl alcohol, now we need to identify what is B, and basically we know that B is aldehyde, but what type of aldehyde it is, because this reaction has aldehyde at its second step. So what is the name of that aldehyde? We are calculating that. So CH3, CH2, OH. We know the aldehyde is being prepared. How aldehyde is prepared? Water gets removed. OH and one water is removed. So CH3, CH, and we know oxidation means what oxygen comes and adds. So this is the aldehyde. So see what type of aldehyde is this? 2 carbons, so ethyl. Okay, and this is aldehyde, so al. So it is known as ethanol, not ethanol. It is ethanol, or in common name it is acetaldehyde. So in these two types, this question can be asked conversion and identification. So these were all about the reactions of the alcohol. Once again, if you see from the beginning, first we learned about the acidic nature. Here simply hydrogen removed, Na comes and adds. Here we learned about types of questions that can be asked. Then we learned about carboxylic acid, which is esterification. It is carried in the presence of H2SO4. Simply water is removed. This is carboxylic acid, this is alcohol. Water is removed and the remaining one you just need to write it together. So ester is being produced, so esterification. So this was carboxylic acid. Then we learned about the phosphorus halide. Very simple. OH removed, chlorine comes and adds. Halo acid, OH removed, chlorine comes and adds. 4 reactions done. Fifth reaction was with conc H2SO4, which had 3 cases. First case 110 degrees Celsius. What will happen? This, in each of the cases, water needs to be removed. So if water is removed, OH removed, H removed, remaining one comes and adds. We just need to write together. So similar to the last case. So CH3, CH2, HSO4. In second case, 140 degrees Celsius, alkene will be prepared. This alkene will be prepared. In the third case, we are using excess, so this ether will be produced. 5 reactions done. Sixth reaction, not that important. Alumina, it is similar to H2SO4. This is the first case of H2SO4, will not be valid here. The rest 2 cases very similar. This OH removed, hydrogen removed, so alkene formed. Here excess, ether formed. And the last one, oxidation. Oxidation, what will happen if we oxidize this alcohol? First of all, aldehyde will be produced in first step, and in further oxidation, carboxylic acid will be prepared. Now the way to remember all this reaction without getting confused is practice. That is the only way. If you practice these reactions again and again, you see these reactions time and again. You simply, if you forget this reaction, you turn your textbook, or you can come to this video and you can simply see what was that reaction. This way you keep on practicing this reaction again and again periodically. You will be perfect in these reactions. You will not get confused, and you will just need to see these reactions once or twice before the examination. So with this we complete the reactions of the alcohol.